So we're back at the optimization section where we talked about absolute extrema. And now we're going to look at this graph given to us here. We're going to address each x value on this function f on the interval from -1 to 6 and identify it as being a relative extrema, an absolute extrema, or neither. So what's important here is that I'm only looking from -1 to 6. So I'm basically just going to zoom in on this graph. So I'm going to put a big box around this. I don't want to get tricked. There's one like this in WebAssign, and I don't want you to get tricked by being given extra pieces of the graph. So yeah, I have this extra piece over here that I do not want to consider. I'm only looking on the interval from -1 to 6, and I want to address each x value as being an absolute or relative max, or maybe neither. So I'm just going to quickly jot down all of the x values I'm looking at. And this is what WebAssign does. They give you every single x value, making it seem like they're all important, but they're not necessarily important. It's just having you address every single one between -1 and 6. So we have -1, 0, 1, 2, 3, 4, x equals 5, and x equals 6. And we're going to call them relative, absolute, or neither for some of them. So I'm going to go by each x value and figure out, is it a relative extrema because there's sign change at a critical number, or is it absolute extrema because I compared a critical number to the end behavior? So maybe before I try to jump into each x value, and I would do the same thing in WebAssign, I would try to figure out where the critical numbers may be and just kind of label what's happening with the first derivative. So I'm going to look just from -1 to 6. If I look outside of my interval of interest, it's probably going to trick me. So I'm only looking from -1 to 6 just because that's what it tells me to. And the derivative starts off with being a negative derivative because it's falling at first. And then I have a soft peak here, so there's a critical number there to think about. It might be relative, it might be absolute, it might be neither. And then my derivative here, it's rising, so I have a positive derivative. This derivative is a sharp corner, so this is undefined. We talked about the places where you can't take a derivative and in the last section, and we said that a sharp corner or a cusp, it's undefined. That's fine. It could still be called a critical number there. So then we have a decreasing derivative, and then it is a constant piece. So f prime would just be 0. And then it's an increasing piece again. This is where it's undefined again. And then the derivative is negative at the end. It's falling. So just kind of getting an idea of what's happening with the derivative. By the way, this critical number has a derivative of 0. I should specify between undefined and 0, just because we did. And now we're just going to go through each piece and figure out, do we have any sort of extrema? So my first number is x equals -1. So in order to be a relative max or min, I have to have sign change. So relative extrema, I need sign change. I cannot have sign change at an endpoint though. If I get tricked by WebAssign and I look at this piece here when I'm not allowed to, it's not on my interval of interest, this might look like a relative max because it's increasing to decreasing. But if I don't have sign change, then I don't have relative extrema. So something that we get from this is relative extrema cannot happen at endpoints. It cannot happen at endpoints because you're looking for sign change, increasing to decreasing or decreasing to increasing, and you're only looking on the interval of interest. This piece is not on it, and if I consider it, it looks like a relative max when it's really not. So -1 is not a relative extrema, but absolute extrema can happen at endpoints. But absolute extrema can. Right? Absolute extrema are all about comparing critical numbers to the end behavior. So the end behavior matters. What's happening at the end of our interval counts. So it could be an absolute extrema. So just because it's not a relative extrema doesn't mean it can't be an absolute. So I'm going to compare this to the rest of the graph. See the big picture. So this is right here. And is there any point on the graph that's higher than this? Well, yes, up here is higher. It gets higher right after this one. It's definitely not an absolute max. So then if I compare this to my other end behavior to see if it's the lowest point around, well, right away it gets lower right after that. So it's definitely not an absolute max because there's higher points, and it's definitely not an absolute min because there's lower points all around. So this ends up being neither. Can't be a relative extrema because it's an endpoint, and it doesn't happen to be an absolute extrema because it's not the absolute highest or the absolute lowest. And then I look at x equals 0 as my next point. It has a critical number. It has sign change from negative to positive. So automatically it's a relative min because it has that sign change we're looking for. Is it also the absolute min? So I'm going to compare that to the end behavior. Well, the left end point is higher, so it could be an absolute min if we're just looking at the left end point. But if we look over to the right side, the right end point is lower than it, so it's not an absolute min. It is just a relative min. So we're done with x as 0. If we look at x as 1, well, it's increasing at x as 1. So there's part that's lower and a part that's higher. There's not even a critical number there to indicate that it's a relative extrema, so it's definitely not a relative extrema or an absolute extrema, so this would just be neither. These things are going to happen at critical numbers or at endpoints, and that's neither of those things. At x equals 2, I'm going to look up here. It is a critical number because it makes the derivative undefined. It switches from increasing to decreasing, so it's automatically a relative max. But more powerfully, is it also an absolute max? So if I compare this y value to the end behavior on the left and on the right, this is the absolute highest point. So more importantly, it is the absolute max. So when WebAssign asks you to just pick one, you're going to pick the stronger one. It's absolutely the max point. It's also a relative max, but it has a box for you to pick, so you would choose absolute max for that. Even though it's both, if you wrote both on a test for me or on a quiz, I would be happy with it because that's true. It is both a relative max and an absolute max. So then we look at x is 3. X is 3 is right here. It is a critical number, but it switches from negative to 0 derivative. That's not the sign change we're looking for. We're looking for negative to positive or positive to negative. So this ends up being neither. It's not lower than all the points around it, so it's not a local or relative min. It's definitely not an absolute min either. At x is 4, kind of the same thing. You switch from a 0 derivative to a positive derivative. So it's not a relative min because it's not lower than everything around it, and it's not a relative max because we don't have that sign change either. It have to be decreasing to increasing or increasing to decreasing to be a relative extrema. Then we look at x is 5. X is 5 has a critical number because it makes the derivative undefined, and it has the sign change we're looking for. Increasing to decreasing, there is a relative max there. It is not the absolute max because our absolute max, we already found it, is higher. If this went up to the same point as that one, then they would both be the absolute max because there's one y value of 5 as the absolute highest y value and 2 locations that go to it. That would be fine. That's just not the case because it doesn't go up high enough. So it's just a relative max. Lastly, we're going to consider our endpoint at x is 6. We already know it can't be a relative extrema because it doesn't have any sign change. It's negative to nothing we are allowed to consider, and it doesn't even go on as a graph to try to trick us or anything. So it's definitely not going to have the sign change for relative extrema, but is this the absolute extrema? So is it higher or lower than all of the other points at the critical numbers or at the endpoints? It actually is. So this would be our absolute min.